Now, there's going to be a little dance of the chairs here. So our next speaker is my co-chair here, Jakob Keiding, and Jakob is going to give us a review of the critical raw material resource potential in Greenland. Jakob.
Yes, well, thank you, and thanks for hosting this meeting in Tallinn. It's a great pleasure being here in such a lovely venue and this nice weather. So I'll tell a bit about the critical raw materials resource potential in Greenland. So I'll address several questions. First of all, where is Greenland? What is about it? Which critical ones and how were they defined? Go through the methodology and give you a very short introduction to the geology of Greenland and some of the provinces we have been looking at. So just a little bit background on Greenland. So we're focusing on Northern Europe, but we also heard this morning that the EU Commission is also having these strategic partnerships with third countries. And that includes actually Greenland. So in 2023, in November, there was formed a strategic partnership on sustainable raw materials value chains with Greenland. Actually, there's been industrial scale mining going on in Greenland for a long time, actually dating back all to the way to 1854 with the Cryolite mine. You can see on the top photo to the right there. So there's actually a long history of mining in Greenland, and Greenland is a huge place. It's really a greenfield exploration, complex geological terrains covering almost 4 million billions of time. But of course, there's also some challenges because of operating in the Arctic, and it's remote and a huge place. So just do like this. So which raw materials have we been looking at? So basically, this is the EU diagram we heard about in the morning as well, where we have the supply risk here on the y-axis and the economic importance, and these 34 critical raw materials, most of them metals, defined in 2023. So we've been looking at the raw materials meeting those criteria, and also the copper and nickel that are considered strategic and therefore are also included in the critical raw materials. Then we also consider some that were nearly critical by virtue of their high economic importance and relatively high supply risk as well. So these are zirconium, tin, molybdenum, and chromium. And then there are the non-critical ones that we have not looked at, all the ones in blue here. How was this assessment done? Well, we have divided into two groups, the known and the unknown. So the known are compiled from probabilist estimates, from exploration reports and by surveys. And some of them are up to like modern standards, but it's also important to stress that many of these are historic and less accurate estimates. Then we also have been using, we have been looking at the unknowns, estimated yearly in mineral resource assessments workshops, where we have applied a USGS approach, delineating areas and then having bidding rounds on first individually and then as consensus. And these are published over the years here, so you can see many of these are critical raw materials, but some of them, for instance, gold, are not. And there are also, of course, some where we haven't done these kind of assessments. Just to show the known CRM resource in Greenland. So these are some of the ones shown by red, different deposits, and in terms of size, according to Inspire standards. So there are 7 large deposits and 7 very large deposits. And if we look at the distribution here, the geographical distribution, we can see we have some in southern Greenland, in what we call the Garda province, and then many also in northeast Greenland. Yeah, here are some of the important ones, like we heard about in the morning from Erik on the rare elements in the Mausak intrusion in the Garda province, for instance. But we also have significant other ones, feldspar deposits and carbonatites, graphite, and so on, that I'll touch more on later. For those of you who like to relate to actual tonnages, here are numbers. It's again important to say that these are historic rather than and not up to modern standards, so they need to be taken with a grain of salt, and they include both measured, indicated, and inferred resources. So for some of them, we only have modest amounts, like for tin, copper, and tungsten. But for many others, they are really significant resources, also for like on a global scale. For instance, for rare earth elements, as already mentioned, but also for niobium, tantalum, and hafnium, for instance. If we look a little beyond the known resource estimate and also consider the potential for unknown, undiscovered deposits, a slightly different picture emerges. We can see that in addition to the rare earth, we also have other commodities, such as nickel and cobalt, but also tungsten and tin and antimony. In total we have high potential for 11 raw materials, a moderate potential for 15, and 7 where we have a low potential. And then some that we haven't accessed because we don't have data for that kind of assessment, or because there is no potential, for instance, for magnesium. So now let's see how the CRM potential is distributed. So the deposits are in red and the provinces are shown in yellow. Of course, significant CRM potential exists in areas where we already know that are also defined deposits, like the Garda alkaline province, Eastern Paleogene intrusions, Archean anorthosites complexes, and carbonatites. But there are also others, for instance, up in the Franklinian basins to the north. I'll now use the remainder of the presentation to briefly present some of these provinces. There's the text here. So first, I will focus on the Mesa Proterozoic Garda Rift in South Greenland. We can see on the map there to the right, the two mostly known and important deposits are the Greenland and the Kvanefjeld deposits shown on the 2 pictures from the Mausak intrusion. In the Kvanefjeld we have stentropine in lurerites, and that's defined a resource of more than 9 million tons rare earth elements. In the Greenland deposits is in this rock type called cacotochites. And we have more than 24 million tons of rare earths, but also significant resources of niobium, tantalum, and zirconium, and hafnium. Then we also have some other deposits like the Igaligo complex, Ivitut, and Isatok mafic dikes. Then we have the Paleogene intrusions in East Greenland related to the opening of the North Atlantic Ocean. there are more than 60 intrusions are known, and although felsic intrusion constitute an important component, most of them are mafic to ultramafic intrusions that are dominated. But both types can be mineralized. And here in the picture to the left, we have the Malmbjerg deposit. It's a huge molybdenum deposit, but also endowment in tungsten and tin. And to the right, we have the world famous Skagon intrusion, known for its layering, and there we have automagmatic deposits of gold and PGE, and also important resources of titanium, vanadium, and possibly gallium. Then there are Kian and Artosite complexes in southern west Greenland. And Artosite is a source for high quality feldspar with low levels of impurities. It's used for demanding and expanding industries such as fiberglass. We have the Mayogaka Kava deposit, where there's actually mining going on by the company Lumina Sustainable Minerals. Then we have another deposit, Kokotoksoak deposit in close to the Fiskeneset area. That's also very high quality feldspar, and some other ones also in West Greenland. Then we have carbonatites. Most important example is probably the Safatok carbonatite complex, shown on the map to the right, and some drill cores from there. It's typically the CRMs are hosted in pyroclar with rare elements, niobium, tantalum, but also resources of phosphorus. Then there is the graphite potential in southwest and east Greenland, related to paleoproterozoic terrains. This paleoproterozoic mobile belts that locally contains carbonaceous material that some places have been transformed to graphite. The Amitsok deposits, we can see these rusty stones here. It's a large deposit in southern Greenland, characterized by its very high grade, and it was actually historically mined back in the early 20th century. But there are two other deposits defined as well in West Greenland and East Greenland, but with significant lower resources. Then up in the north, we have the Thule black sands. These are another deposit type with heavy sands from placer deposits derived from silts and dike in the hinterland. It's of course quite easy to extract compared to many other places. There's a large resource defined for Morisac, and also a smaller deposits in the vicinity of this. Then the previous areas where the significant deposits have already been identified. So now here in the end, I will talk a little bit about the areas where there are no occurrences, but where no deposits have been delineated yet. So an example of this is the East Greenland caledonites. We have reduced Silurian and Devonian granitic intrusions, hosting a potential for tungsten, tin, molybdenum, and other CRMs. Some of them are in mineralized veins, as you can see on the picture here to the right, or in Bison and Skand deposits. So there's only smaller occurrences been discovered, and work is still going on in terms of exploring these. Then we have some sedimentary basins in East Greenland, Neoproterozoic Eleanor Bay supergroup, thick succession of more than 8 kilometers that has potential for copper. There's also the primary Triassic Jason and the land basin related to continental breakup. And these are like kupferschiefer analogs so that are being exploited here in Poland, for instance. And there are also actually a large deposit of strontium from the Karstrøkken deposit in this area. West Greenland Paleogene province. I talked about East Greenland earlier, but this magmatic province actually started in West Greenland. Not been defined any deposits here yet, but there's a potential for conduit type nickel copper PGM mineralizations, akin to what we find in Norilsk in Siberia. Low contents of these elements in some contaminated lavas, and could suggest sulfide saturation took place. But probably at a shallower crustal level than in Norilsk, and as active exploration going on in this area. And there probably needs to be done more drilling really to assess whether it could be an analog to Norilsk or not. Then the Franklinian Basin in North Greenland. So the map shows here to the left highlights potential for zinc for one of these MRAP workshops. Zinc is not by itself on the list of critical raw materials, both MVG and ZX type zinc mineralizations here, but could be potential for associated gallium and germanium enrichment. We've seen that in some of our samples, and it's often associated as a byproduct, but we have limited data at this point, so probably need for some more further assessments in terms of analyzing historic samples here. So just to wrap up and conclude, the CRM endowment of Greenland considered plentiful in many cases, comparable to well-established mining regions such as Australia, Canada, and Scandinavia. We have to keep in mind that the resource figures are often historic estimates and not up to modern standards. The very large rare deposits, like in Mausok intrusion, both of Greenland and Kvanefjeld, and some of the satellite intrusions associated with Kvanefjeld are also mentioned here. Then there are the very large Malmbjerg molybdenum deposits, the very large Karstrøkken strontium deposits, and also large feldspar deposits. Then in terms of the more general potential for CRMs where we don't have deposits, we have to keep in mind the relatively unexplored status of Greenland. So could have potential for tin, tungsten, and antimony in vein, and skarn Grayson deposits. Then, as just mentioned, the nickel, copper, cobalt in magmatic deposits of West Greenland, and then possibly in northern Greenland also germanium and gallium as a byproduct in the Franklinian basins, and then finally the graphite deposits in the Paleoproterozoic terrain of south, west, and East Greenland. And with that, I'll just say thanks for the attention, and here are some of the publications related to this work. Thank you.
Thanks very much, Jakob. Any questions for Jakob? Holly. Wait for the microphone.
This is a question for you guys. Can we go back a slide so we can get that web page at the bottom, please? Thank you.
Any other questions for Jakob? Yes.
Yeah, Torkel Rasmussen from Luleå. Question here when it comes to the future on Horizon Europe projects and ERAMIN projects. In the past, Greenland has not been a member of the ERAMIN community. What about the future? Because as I see it, when it comes to Horizon Europe calls, there are almost no calls on exploration. And I have the impression that it's going into ERAMIN. So is there an intention to go or be a member there?
I know there's an intention to be a member from the state of Denmark, and I think that there's also the possibility to have collaborations with partners not being part of the network, but still being involved in projects. But I'm not aware of that Greenland itself is going to join, and I don't think that's actually possible, as they're not members of the EU Commission or the EU.
Okay, thank you.
One more here.
Thank you. Preet Jers from Biotatech. Now, we all know that the Greenland is one of the thickest glaciers currently, like up to 3 kilometers, but they're retreating. So any indication how those retreating glaciers will change, if change, the current geological prospect of Greenland? Are there any deposits that are actually extending right now towards under the glacier that would become available once they retreat in the near future?
Well, there is the Isua iron deposits in West Greenland that's very close to the inland ice. That might be easier to exploit if the ice is retreating further. And of course, also, possibility for new other deposits being easily accessible. But of course, we don't know, very much about the bedrock geology underneath the inland ice. So, but yeah, there might be a potential there. But I think it's even more important in terms of with the increasing temperatures, that access to Greenland could be easier in the future. So some of the deposits that are in the East Greenland or Northeast or North Greenland that are where you have ice all year round, they might be easily accessible in the future, for instance.
I don't have a geology background. That's why I'm asking if the area below ice right now is potentially as rich bonanza as the coastal areas.
Yeah. But we don't have the data really to say that. We have some.
It's a guesstimate.
Yeah. There's been made a very crude map of how we expect the geology underneath the inland ice to look, but based on geophysical evidence and boulders, for instance. But we don't know that in detail yet. So,
okay, thank you.
Yeah.
Thanks, Jakob. That was a very political answer, I feel, since we know that many of the structures do extend underneath the inland ice. Right, unless there are any more questions. Florian, go ahead.
So we have a question from Pedro, and he's asking, are there any information on environmental or social constraints of CRM development in Greenland? Are there more or less sensitive areas?
Well, that's a good question. Well, it's my impression that in general there is interest in extracting and using the resources, the mineral resource of Greenland. The Greenlandic economy is very dependent on fisheries, for instance, now, and also interested in being independent of Denmark economically. And of course, mining could be one way to be more, for them to be economically independent of Denmark. But of course, there are areas where it's also complicated. particularly around, for instance, Nasak and the Kvanefjeld deposits, where there's a relatively high content of uranium, and there's been a change in terms of legislation there. So now you can't, explore or extract resources with more than 100 ppm uranium. So I would say it's a big, both pros and cons in terms of that, from the side of the acceptance that, there's of course a wish, but there are also concerns, so a bit of both, yeah.
Thanks, Jakob. Right, we're going to move on because the next speaker never keeps to time. So we're going to swap.